Good morning, YouTube. So here's one I have avoided and I still should avoid because this isn't going to help very much at all. But it is about energy measurements because it comes up in so many conversations from different directions, different ways. So when energy is measured, it's measured very specific ways. Some people understand all the rules, and some people just know how to go take a measurement, and that measurement's fine. Because knowing all the rules doesn't change what the meter is going to tell you when you plug it in. You just have to know it's going to measure DC, or the meter might figure it out. It might auto range and say you've got DC or AC if you're doing voltage measurements. Now, voltage is potential energy. When there's a difference in voltage, there's energy there that you have to be aware of. If it's DC, it's DC voltage. If it's AC, it's a sine wave. It's AC voltage. Now, AC, the sine wave implies a frequency, right? Frequency equals 1 over time. Remember, all of these equations are related. They're little pieces of a big picture. No one of them stands all by itself unless the rest of them are either ruled out or accounted for. But generally, to bake a cake, you're not worried. I mean, you want to know your oven's at 350, but if you knew the truth about the oven temperature, you might change the temperature settings, right? So these are all little discrete measurement things that go on. And you add some complexity in here because your measurements, if you're a carpenter, you're using inches or meters. Pretty much carpenters don't use miles and, speed. Their boards don't go 50 miles an hour unless you're worried about a hurricane, which they are when they build the house. They want it, pretty sturdy. So these measurement things, they come across in all types of ways and matters. But each thing, if it's voltage, if it's amperage, if it's watts or power, if it is gigawatts, if it is expressed as a frequency, so in hertz or kilohertz or terahertz or gigahertz, or all of these things are frequencies until you get down to DC, and now you're back in kind of a different world. A little bit different, not a lot. It's potential energy, but it doesn't alternate. So these are the energy measurement confusing things. Now, to add another layer of confusion on here, after the Fukushima event, because of the confusion in energy measurements, I think I could name 6 ways that people might recognize as energy measurements. More than that, there's lots of, it can be in Gauss, if it's magnetic energy, right? We measure Gauss. That's magnetic field strength. We measure, now, magnetism is not electricity. Magnetism is a different force than electricity, but electricity can induce magnetism, right? So it's how fans and motors and everything else works. The electric energy is turned into magnetic energy that pulls that little motor around in circles. And it can be tens of thousands of circles or 1 circle a minute. So this frequency, this time period, these are all parts of measurements that are taken into account at whatever is necessary. Right, a carpenter's using 1/16 of an inch. It's probably as good as his tape measure gets, or as his measure gets. And if anything, he's going to be 1/16 of an inch long and then sand it off or finish it off. So these measurements make a difference. how you use them makes a difference. A carpenter is more aware of a ruler than a housewife is, more aware of a ruler than a teenager might be. So, measurement things. What does it have to do with Fukushima? I was speaking to the types of measurements you can do, but radiation measurements at Fukushima became a problem when sharing information across global agencies, when sharing information with the Navy, when sharing information with the public, because you can't tell the public the same thing you can tell everybody else, right? We know these rules. It's a secret. Don't release it. Don't tell it. Try to figure. It's the first level of cover-up happens in this investigation phase. It begins right there when somebody signs a $1 million appropriation to go investigate something. And in my context, it's nuclear waste somewhere in a neighborhood, in a school. Okay, those were triggered by federal actions and state actions that are written down, and a process is followed because you can construct a price and a cost for a process. So the measurements are hugely important. What they discovered at Fukushima was that because the agencies were not talking the same languages, that it was being misinterpreted. It was not being interpreted, it was being misunderstood between agencies. It may have been what left an aircraft carrier and support group vulnerable to radiation. They didn't know how to talk to each other. So, a lot of people saw this, a lot of people noticed this, including one of our premier institutions, right? National Academy of Sciences. So, shortly after Fukushima, they commissioned a study to make recommendations for standardizing radiation measurements. It is that important. The National Academies put together a study that needed to be funded because guess what? Republicans don't give a fuck. So, and Democrats, wealthy Democrats don't care either. They don't understand. They don't have a friggin' clue. The people talking to them are politicians and salesmen. And that's who brings them the money that they listen to. So, Fukushima and measurements, this was brought up again. This happened at Chernobyl. It did not happen as much at TMI, but it still did. And some of it is in giving Geiger counter readings when you need spectrometer readings. And again, that spectrometer back in those days was $100,000 instruments. $100,000 instruments that were calibrated and certified and had organizations verifying that they did what they were supposed to do. These Geiger counters are not a joke, but they're also not very accurate. Right off the bat, 30% accuracy, that is the best you can guarantee with that. And then you multiply those errors when you do multiplications on a wrong reading. So, these measurement things are hugely important. I don't know how to convey what's missing, I would guess, when people talk about these readings. Again, a Geiger counter is a very general, it's a canary in a coal mine. If the canary's dead, it could have been any number of things, but either way, you leave. You grab the canary and want to find out why it died, but when it's dead, you leave. So Canary 101 gives us a hint about the real world. So these measurements, these about 20 different nuclear measurements that get thrown around and misused and generalized, totally hurt the conversations. But if the audience doesn't understand that, how do you introduce those ideas, those thoughts to them? That an instrument, 60 years in the development, in the improvements, in the specificity to parts per billions is where we are. 12 digits of precision in both directions, and better now. And yet, we're arguing about 12 inches. So, it is frustrating. There seems to be a reason why too many people don't understand why this is important. And that makes this whole conversation frustrating, because you piss people off on the way by. You're talking about the real world and real harm, and other things come up. Really. A poisoned fetus. A poisoned fetus. You want a right to life? You want a true right to life? You begin with what's going to kill that fetus. And it's not an abortion. It's not a woman's choice. The odds are there's many more things. So, and in this, I've been kind of waiting. My hummingbird feeder's behind. I don't know if you'll be able to see them. Try and get it to focus on them. Nope. So, these energy measurements absolutely matter. The energy includes frequency because of math. Because of simple math that can get very complicated depending on how close you're looking at the particles. General measurements around the house measurements. Okay, water, quarts, liters, cups, gallons. Electricity, you have AC voltage, which is usually just your house power, right? 120 volts or 220 if you've got an electric dryer, or an air conditioner, or whatever. Lots of houses have 220 volts, which is two 120 volt circuits or 110 volt circuits, right? That's kind of squishy numbers that are in there. When you stick a meter in the wall, you'll usually see something under 120 volts, which matters in power measurements, but who knew that? Behind that, if you've got a frequency counter, you can look at the line frequency coming into the wall. This is why old clocks were very imprecise. They lost time if they ran off of wall power, because they were using the frequency of the wall, 60 hertz, to spin the clock. So if the wall frequency was only 58 hertz, the clock would go slower, or if it was 62 hertz, the clock would go faster. So that died pretty quickly as a method of precision time. So very few systems use that clock anymore. But some systems do use it. They'll use that 60 hertz signal because it's close enough to count something. So there's a precision. Do you need the precision of 62 hertz or 60 hertz? And basically new instruments don't care. But so the other part of that was DC voltage, different measurements. More house measurements. If you've got a Wi-Fi router, you can get a little app that will tell you how many decibels of energy that Wi-Fi router is emitting. Now, decibel is a unit of energy measurement. It's like a power measurement. 3 dB is a half power point, if that helps anybody out. dB usually used for audio measurements to measure volume, but it can also be used to measure. It's a measurement. It can be applied to anything, but generally audiophiles in volume talk about decibels. Noise pollution talks about decibels. Elemental particles talked about air pollution and parts per million of a specific size particle. So that's, you're measuring in microns now. The finest particle we measure to is 2.5 microns, which is a very, very large molecule. That is tens of thousands or even millions of atoms in that one little clump of something. So atoms are tiny, tiny, tiny little things. Tiny, real tiny, and they're smaller than that. So all these measurements are confusing. National Academies of Science could not get federal funding to try to put that story together. To me, that was about the fourth largest tell of the insincerity of science and politics in understanding the health of our population, right? Because it's about us. It's not about me. It's about us. So right now I'm at 15 minutes, and I haven't even begun to sink into the different kinds of particles. This is a thesis. You're in master's and doctorate level relativity conversations about many different things if you're in particle physics. In particle physics, you're below the electron level. You're below the molecular level, but everything molecular exists. So the particles we generally talk about on a nuclear level are electrons, because they're so tiny, and they move with subatomic properties. They spin, they disappear. Then we measure photons. Photons are a product of electron movement. They are a very specific type of particle with a very different mass, with very different harm potential. The frequency basically sets the harm potential because these interact with skin characteristics. The easiest one to refer to is cataracts in the eyes. They happen very slowly. They happen from mostly exposure to sunlight. But cataracts are also a symptom of exposure to radiation. You can get cataract exposure. Now, the cataracts won't show up for months or years after your radiation exposure, but that energy dose was so much higher than the energy dose we get from sunlight in the UV spectrum that causes cancer, it's not cancer. A cataract is not cancer. It's a degradation of the lenses in the eye because they're crystalline structures, and once you begin destroying them, there's no turning back. Well, it's hard to turn back, although science is working on turning back that crystallization inside the eye. It's freaking amazing. Another personal story. It's not mine to share, but there's another 3 months worth of conversations around the effects of diabetes and the high price of insulin in measurements. So we're back on measurements. So Fukushima mattered. Fukushima triggered the premier global science academy. The National Academies of Science saw that as enough of a problem that they needed millions of dollars to try to even make sense of what happened. It is a crime scene investigation that they were trying to do, because our sailors got impacted, probably because we weren't talking the same language, or it was a secret. That's the bigger thing. It was a secret. They could not talk about this. That's the killer. That's what's killing our sailors. That's what's killing the workers at TEPCO Japan. The reason Fukushima. To clean that up, for the last many years, they have used foreign labor, huge amounts of foreign labor. And yes, they moved the men through there quickly, but the men were desperate for paychecks. So you take that kind of money back to Vietnam, back to any of the Asian countries, back to India, you are well off, my friend. After you pay off all the people that you had to bribe to get the job overseas and the paperwork to be there. So now you go home contaminated with radiation. Who knows if it's genetic and your children are going to be affected, or it's just going to be you affected. Or when the worms eat you and die, if it'll be your grave is infected. These are just what, the cycle of life, the measurements of life. So that study was scuttled, and that I've got a year of conversation about that in Facebook, when it happened and what the games were, and people just don't get the importance of these measurements. they're easy to do now. That's the bigger kicker. The instrument, it would take $50,000 to walk in with a certified instrument, the software, and the analysis analytic capabilities to do just for the instrument and the software licenses. And behind that instrument is a lab and a test procedure and other things that cost a lot of money, because once you find gold, you have to verify it's gold. So what does it mean? What does it mean? I haven't got a great answer for you, but I talked about electrons. I talked about photons, which are discrete, separate particles from an electron, but they were caused by an electron's movement. So if you're measuring photons, it is something different than measuring electrons, yet they are related, relationships, okay? And these get into statistics, calculus, differential equations, and whatever is beyond that. I mean, statistics alone is become a actuarial person that assesses the cost of costs, assesses the cost of expenses. All these are professions that are out there that are tiny little holes, pocket holes in our knowledge banks that don't talk to each other very well. So again, we'll go to what does it mean? It means people can create very poor conversations about very real things. And you can put beliefs in here to confuse even more people and make them defensive. That's the biggest thing, is making people defensive, triggering them so they lose sight of the goal and go after the players. So this is a really long one. High energy particles, we're talking about alpha, beta, gamma, and maybe even neutron, and some other particles, depending on where you are in the core of the reactor, near the core of the reactor, far away from the core of the reactor. Is it a distributed source or a point source now? Is there no way to get away from it, or can you put some distance between you and it? It is 14 equations all coming together to make decisions, not one friggin' equation poked with a stick. So there's a long one. This is an answer to a couple of question videos. It's another different lead-in to particle energy measurements. When you get into quantum mechanics, you're almost purely at an energy level where particles have no mass that we understand now. It breaks equations where you divide by zero. So those equations have to have other equations. This is what E equals mc squared knew. There was something missing there. But E equals mc squared was so close that it was good enough for government work. Decades ago, we weren't this precise. We didn't know. That was the closest fit answer, just like the equation for gravity is a best fit answer. It is much better than any of the other things, the words that people try to use. So those semantics games are grade school, middle school, high school level games that get carried on into college and the cliques. And you're not there to learn, you're there to make friends and hopefully get a good job from a friend. You know how this works. Too long, 25 minutes. And I need to light my cigarette. Didn't want to smoke in front of everybody's. Pieces, so many pieces. Don't make it simple. Argue about a zero that doesn't exist. Thank y'all. Do appreciate it. Really long one.